All right, let's go ahead and get started. I do want to welcome you to the fifth installment of Unit 0. We're going to be talking about something called significant digits. Now, what do we mean by significant digits? What makes a digit significant? Well, first of all, when we measure a number, say for example, if I were to take this number right here, 45.2, let's say I'm measuring mass, so we're going to say that that is grams, 45.2 grams. What do I mean by that? Well, what I mean is that I've measured 40 grams plus another 5 grams plus another 2/10 of a gram. That's what I mean. But what if I do this? What if I measure 45.20 grams? What if my measurement yields that? What I mean by that is, in my measurement, I've measured 40 grams plus 5 grams plus 2/10 of a gram, but I've also measured, and my instrument has the capacity to do so, to the nearest hundredth of a gram. It just so happens that it's 0 hundredth of a gram. It's 0 hundredths of a gram. So I'll report my answer as 45.2. The point I'm trying to make is that we have to make a distinction between what numbers are significant and what numbers are simply holding a place. So with that, we're going to need to know a couple of different rules. The first one is this. Leading zeros are never significant. Leading zeros are never significant. So for example, if I write 0.024, the 2 zeros in front are only holding places. They're not significant, right? It doesn't matter how many zeros that I have in front. I can have a lot of zeros in front. Those zeros in front will never be counted as significant. So leading zeros never count. Okay, leading zeros never count. That's our first rule. The next rule is that trap zeros always count. Now, what do we mean by a trap zero? If I write, for example, 4501.6, 4501.6, well, this zero right here will count as significant. This zero right here will count it as a significant number because it's between two non-zero digits, right? So significant zeros are trapped between two non-zero digits, but leading zeros don't count as significant. All right, so that's the second rule. Next rule, trailing zeros count, but only if there's a decimal in the number, and that decimal can be anywhere in the number. So let's just say that I have 21.40. Does that zero count as significant? Well, the answer is yes, because there is a decimal somewhere in the number. That decimal does not have to be right next to the zero, right? It can be anywhere in the number. So yes, that zero is significant, and I would say that 21.40 has 4 significant digits. But what if I had this, 240, just like that? 240, this zero right here is not significant. It's simply holding a place. I'm saying I don't really know what goes in that position right there. It may be a 1 or a 2. My instrument just does not have the capacity, does not have the precision to be able to determine what that number is. So I simply have to distinguish this number, 240, from, say, 24. I don't want to delete the 0 because that would make my value off by a factor of 10. So I'm going to put 240. I'm going to use the 0 to hold a place, but I really don't know what that value is. Now, watch this. What if I put a decimal right after the 0? Watch what that does. Now there's a decimal somewhere in the number, and the 0 does count as significant. I have an instrument which is capable of measuring to the nearest 1, let's make this grams, to the nearest 1 gram. It just so happens it's exactly 240 grams, okay? So, trailing zeros, significant, but only if there is a decimal somewhere in the number. Remember, that decimal does not have to be right next to the 0. It can be anywhere in the number. And then, of course, all non-zeros count as significant. All non-zero digits count as significant. All right, so let's see where that takes us. Let's do some practice. Oops, here we go. Sorry about that. Determine the number of significant digits. Let's take this first one, 0.00354. Now, all three of the zeros, all of the zeros here are leading zeros, right? And because they're all leading, we follow the rule of leading zeros are never significant. So we're going to say that there are only a total of 3 significant digits, the 3, the 5, and the 4. 3 significant digits in this number. Let's take a look at this number. We've got 0.00. Those zeros are leading. They don't count. They're not significant. But this 0 is different. This is trapped between two non-zero digits, so it's significant. So we have 3, 0, 5, 4. We have 4 significant digits just like that. And finally, 0.00, those are not significant because they're leading zeros. 3, 0, that 0 is significant because it's trapped between two non-zero digits. 4, 0, this 0 is a trailing 0, and trailing zeros count if there's a decimal somewhere else in the number, and there is. So how many total significant digits? 1, 2, 3, 4, 5 significant digits. 5 significant digits in the number 0.00305440. Okay, we're going to get a lot more practice on a worksheet or a series of worksheets, but that's enough for now. So now we know how to determine the number of significant digits in a single number. Let's take a look at calculations. So these are rules for calculating with significant digits. So we're going to consider addition and subtraction separate from multiplication and division. So let's take a look at this addition problem right here. We have 1.457 plus 83.2. How do we do this? How do we determine the number of significant digits in the sum? Here's how I do it. What I do is I simply use a calculator to add these numbers up. 1 plus 3 is 4. This 8 comes down. 4 plus 2, 6. Bring the 5 down. Bring the 7 down. I get 84.657. But I cannot keep all those significant digits because here's what I want you to notice. I have to go by the least precise measurement. This 83.2 measures only to the nearest tenth of a whatever it is. The 1.457 measures to the nearest tenth, 100,000th. But the fact that I have a number that's being added that measures that's only precise to the nearest tenth means my answer must be restricted to the nearest tenth only. So even though the calculator gives me 84.657, I have to round that number to the nearest tenth. Now, how do I do that? Well, I find the number in the tenth position. It's a 6. And then I look to the right of it to see if the number is 5 or bigger. It is. If it is, I'm going to push that number, which is a 6, up. And I would push it to a 7. So I get 84.7 for my final answer. So when I report 1.457 and 83.2, 1.457 and 83.2, I have to report my answer only to the nearest tenth, and I round using the technique that I just showed you. I get my answer as 84.7. Now let's look at a subtraction problem. We got 0.0367 minus 0.004322. Now when I do that subtraction on a calculator, what I get is 0.032378. But I can't keep all those significant digits. I have to look to see which of the two is least precise. The 0.0367 measures to the nearest tenth, 100th, 1000th, 10,000th. The 0.004322 measures to the nearest tenth, 100th, 1000th, 10,000th, 100,000th, millionth. Okay, so I'm going to take the least of those two, which is the nearest tenth, 100th, 1000th, 10,000th. I can only go to the nearest 10,000th. So when I do that in the calculator, I get 0.032378. I'll round that to the nearest 10,000th. That means I'm going to go to the 10,000th position, which is this 3 right here, and look to the number to the right of it. If it's 5 or bigger, I'll push it up to a 4. If it's not, I'll leave it as a 3. Sure enough, it's 7. That's bigger than 5, so I'm going to push it up to a 4. And I report my final answer as 0.0324, just like that. Now, that's the rules. Those are the rules for addition and subtraction. Look to the least precise number being added or subtracted, and make sure that your answer round so that your answer is to the least precise of the two. But what about multiplication and division? Well, let's take a look at this problem right here. 4.36 times 0.00013. This time, I'm not concerned about which one is the least precise. I'm only concerned about which one of the two has the least number of significant digits. 4.36 has 3 significant digits, but 0.00013 has only 2 significant digits. I can have only 2 significant digits in my solution, in my product. Even though the calculator gives me 0.00056668, I'm going to round that number to 0.0005. Do I push the 5 up? Yes, I do, because 6 is bigger than 5. And so I'm going to push that 5 to, excuse me, sorry, I'm looking at this. 6 is bigger than 5. That's going to push this 6 up to 7, so I'm going to report my answer as 0.00057. Let me do that for you one more time, because that might have been confusing the way I explained it. So let's take a look at it again. I can only have 2 significant digits total in my answer. Now my calculator gave me this, 0.0005668. However, I must round to the nearest, to only 2 significant digits, because of the 2 significant digits in this product right here. So how do I do that rounding? Well, I have a 5 and I have a 6. Those are the two digits that I'm interested in. Remember, the leading zeros are not significant. The question now becomes, do I push this 6 up or not? Well, the next number over is a 6. That's bigger than 5. It's not just 5, because remember the rule is if it's 5 or bigger, I push it up. It's 6. So I'm going to push this 6 up to a 7, and I report my answer as 0.00057. Okay? Let's take a look at this quotient now. We have 12.300. We're going to divide that by 0.0230. The rule again is look to see which one is the least significant of the two. And when you determine that, what you're going to do is you're going to write your answer to that number of significant digits. The calculator gives me 534.78261, but I can only have 3 significant digits. So I'm going to look to this 4, that's the 3rd significant digit, and ask myself, do I push it up or not? Indeed, I do. 7 is bigger than 5, so I'm going to push this 4 up to a 5, and I get 535. That's my final answer. That's the product that I'm looking for. Okay? Does that make sense? All right. So that's determination of significant digits of individual numbers, and then determination of significant digits when I'm talking about addition or subtraction, and finally, significant digits when I'm talking about multiplication and division. In the next one, we're going to be talking about scientific notation, and we're going to be doing some challenge problems. I'll see you then. Thanks. Bye-bye.